Manufacturing and industrial environments provide their own unique challenges for wireless communications. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. This is where we come to discuss those challenges, share ideas, and help one another out. My name is Scott McNeil, and welcome to the Industrial Wi-Fi Shop. Welcome, everybody. This is the Industrial Wi-Fi Shop. My name is Scott McNeil. With me, as always, is my color commentator, Jeremy Baker. Say hi, Jeremy.
Hello, everybody.
Today is going to be a great show. We've got some great content coming up, but before we dive into that, I do want to talk about our CWISA Guide Giveaway. I am giving away 2 copies of the Certified Wireless IoT Solutions Administrator book from CWNP. There will be 2 winners. One will be from IT, one will be from OT. In order to enter, all you have to do is go to the industrialwifishop.com, hit this episode's show notes, and there will be a handy dandy link to a Google form for you to fill out for your official entry to win one of these books. So it's super exciting. It's a good time. It is incredible information. It will really help expand your horizons. If you're in wireless and you want to know more about the IoT stuff, this is a great way to go. If you are in OT and you want a baseline understanding of how all this stuff works, this is a fantastic book for you. And it also preps you for the certification exam. So don't forget, hit the industrialwifishop.com. Hit episode 9 show notes, click the link, fill out the form, accept the malware. Just hit enter, and you will be in the drawing that we will do on episode 10. So now for today's show, it's Wi-Fi Fight Club, Wi-Fi 6 versus 5 and 4. The whole deal with what's going to be better for your applications and industrial manufacturing environments. And today joining us is my friend Vic Perangelo, and Vic is from ProSoft Technologies, which is a very large industrial manufacturing company that makes stuff really across the board, not just radios, but a ton of various electrical components and industrial components. I challenge you to walk into any manufacturing site and not find something ProSoft in their OT systems. Vic, how are you, sir? Tell us a little bit about yourself.
I'm doing good. Good morning, Scott. Good morning, Jeremy. Yeah, so hi, everyone. My name is Vic Perangelo. I'm with ProSoft, but technically speaking, I'm with Belden, right? So ProSoft Technology is a Belden brand, right? So if you think of Belden brands, you're talking ProSoft, Hirschman, Lumberg, Alpha Wire, obviously Belden Cable, but there's a lot of others, PPC, Macmon. But my history in working with Scott has really been sort of narrowed down to the ProSoft arena, and Scott's right. You know, ProSoft was actually founded on protocol conversion, right? So back in the late 1980s, when guys were trying to figure out how to port over stuff from a PLC-2, PLC-5, PLC-2, or SLC 500, protocol conversion, or even getting machines to interact, right? How do you get a Rockwell system to talk to a Siemens system on Profibus, Profinet, or Schneider, or whatever it might be? So that was always ProSoft's bread and butter. But in my time with ProSoft, the last 6-7 years, I've really gone deep down the hole of using industrial wireless Ethernet in a lot of applications. I mean, very cool stuff, right? You got amusement park rides, water, wastewater, a lot of automotive, food and beverage. My particular specialty, by default, just happened this way, is material handling. So anytime you got like mobile bots, let's say in a warehouse, automated conveyors, things that automated forklifts, loading, unloading. The biggest one would be like automated storage and retrieval, right? Where you're just bringing in product and you're taking out product, and the warehouse is lights out. There's no people there. It's, could be 300, 500, up to 1,000 robots working under that warehouse roof, bringing product in and taking it out as my wife orders it on Amazon.
Well, who's not an Amazon addict these days in the grand scheme of things?
Right.
No comment.
Prime.
So one of the interesting things with ProSoft radios is currently uh, the majority of your lineup is all Wi-Fi 4, right? So it's 802.11n. But when you look at the applications, there really is no need to go higher than that because overall data throughput is minimal. It's not, gobs, and it's not HD video, it's not 4K. You're not trying to cram all that through. And typically you don't run VoIP across industrial wireless either. For all the applications that we tend to talk about, it's generally machine to machine communication, and it's some kind of protocol, whether it be an actual controls protocol or sensor data or something along those lines, or bots receiving their orders back and forth. And when you look at that, the actual volume of data is not great, but the criticality of that data from getting to point A to point B is a whole lot more important. And then the latency in combination with that, right? So it's got to be there as fast as humanly possible. And it's got to be reliable, consistent data. There's just not a lot of it. So
No, you're right. You're right. When you start, I always think of comparing like the enterprise IT needs to the OT needs. In our world, in the ProSoft world of mobile bots, a reliable connection, especially through the roam, and I'll get into that in a minute if you listeners don't know what that is, but a reliable connection is like the most important thing. I mean, you've got in the OT space, you've got customers doing SIP safety, you've got safety IO, whether it's SIP safety, ProfiSafe, other safety protocols. These things rely on a reliable connection, and they're sending out a heartbeat. And if they miss a heartbeat, or if they miss two heartbeats, that bot's going to stop. Now that stop translates into downtime, it translates, lost revenue, whatever it might be. It might require somebody to manually walk into the site and drag the bot out, but it causes these what we call nuisance timeouts. It's like nothing really went wrong except that the wireless system wasn't fast enough to do what the automation and safety system needed it to do. So instead of us sending, like you mentioned just a second ago, instead of us sending large packets, we send a lot of small packets, but we rapid fire them. They just keep going, little. And that's the challenge that we see in using, let's say, Wi-Fi 4 versus a Wi-Fi 6, and the features that both have and how they handle or don't handle that requirement.
yeah, I could definitely see where the nuisance stopping is one thing, but you combine that same concept, like Jeremy, with rides and parks. That nuisance stop then can translate into a safety issue too if you have people on board. If it's a bot with people riding on it, right?
Upside down on a roller coaster.
Yeah, it's all
How
about
often has
latency,
that been
not
happening
load.
here lately? Holy cow.
It hadn't been my fault. I know that. But yeah, I mean, that's like even in our reporting, there's always like a blurb that's just, like AGVs are extremely sensitive to like layer 2 retransmission. And so it's all about like latency and not the load.
The other thing I touched on was like the roam time, right? And for anybody who doesn't know what a roam is, I like to give the example of in my house, I have 3 access points, right? I have an access point on one side of my house, maybe where my office is, and have like another access point in the middle of the house. And then I have the third access point, like at the far other side of the house, which is, let's say, my bedroom. So it kind of create a mesh within my house. And if I were watching Netflix on my laptop in my office, and I started to walk from my office towards my bedroom, what's going to happen is at some point while I'm walking, my laptop's going to say, oh, he's getting further away from the access point in his office, but I'm starting to pick up strength on the access point in the middle of the house. So it would switch over, right? That's the roam, that's the hop. And as I continue to walk towards the bedroom, the same thing would happen again. It would recognize, okay, I'm getting away from that access point in the middle of the house, but the signal strength from the access point in the bedroom where I'm heading is getting stronger. So it would roam again. Now, when you're watching Netflix and your laptop is buffering whatever it's bringing in, it's not a big deal. But when you're talking about, bots roaming around the warehouse with safety protocol, and things have 20 millisecond, requested packet intervals, RPIs. then that roam, during that roam, there's like a finite amount of time where you lose contact. You basically like lose connection to the access point. So it's a little bit of a blackout. It's short, but it's still there. But where ProSoft has been able to sort of conquer this issue is if these RPIs and then these timeout limitations are on the order of 20 milliseconds, 40 milliseconds, the ProSoft radio roam time is under 10 milliseconds. Very often 2 milliseconds if you're using a ProSoft radio as the client and a ProSoft radio as the access point. So we sort of take that problem out of the equation. We roam faster than the timeout or the RPI would time out.
Well,
Does that make sense?
That's significantly faster than just standard roaming where a separate client is making the decision to roam from AP to AP, like my phone or a laptop. I mean, because that can be a few seconds. But you're absolutely right. With these kind of applications, they require that low transition time, that radio to radio transition time. How are you guys able to achieve that sort of sub-second hop radio from radio?
So in the Wi-Fi 4 chips, like, if you think about it, ProSoft's, we're building all the radios in North Carolina, right? We buy a Qualcomm chip, we package it into, an industrial housing, like you've seen, whether it be like a IP20 DIN rail mounted housing or even IP67, a real like boat anchor type of thing that can take a beating and stand the weather. But then what we do, we play some games, right? So ProSoft, with the Wi-Fi 4 chip, we can kind of reach into that chip and get access to some of the low-level functions. So instead of relying on the chip to do what it normally does, which is, follow the industry standard in terms of how to roam, we're able to, let's call it with secret sauce in our software, we're able to do that decision-making ourselves. The ProSoft radio, while it's connected to an access point, is scanning up to 75 other access points, deciding when to roam. But it's like ProSoft is deciding when to roam, not the Qualcomm chip. That's how we do it.
That's pretty impressive. And that kind of low latency you handoff that's impressive. I mean, any radio that can do sub-second handoffs is impressive. But when you're talking down to less than 20 milliseconds, man, that's hard for my brain to actually wrap around because of how fast that actually is.
Let me qualify that a little bit. So we advertise sub 10 milliseconds, and all the data I've seen it down to 2 milliseconds. Fairly common. But that scenario requires, like I said before, ProSoft client, ProSoft access point.
Right.
I had a customer recently who needed that type of roam time, but there was a third-party access point, right? So it turns out it works out well because all of the secret sauce that we're talking about here happens in the client, not the access.
So
point.
even with a third-party infrastructure, using a ProSoft as your client radio, you're still able to achieve really fast roam times. Is that what we're talking about?
We haven't gotten under 20 milliseconds, but we're still down there. Yeah.
Well, that's
so still not as good as the ProSoft to ProSoft, but ProSoft.
No, understood, because you can't control what the other manufacturer's infrastructure radio is doing.
We don't have the knobs and buttons to twist
right.
Like we do on ours. Right. Correct. Yeah.
That's where you just take the lid off the other radio, leave the LEDs on, and then put one of your radios behind it.
Well, so there's been a couple situations where exactly kind of almost what you just said, Jeremy. The customer decided, well, look, we're going to replace all the radios in the box, put ProSoft in it, and do that, third-party access point. They didn't want to touch the infrastructure, right? They still had the backbone, whatever switches, whatever access points. And in some occasions, they were like, all right, let's see if we change them, what happens. And I've got actual data. So we had one instance where when the customer just changed out the clients in the box, they had a 70% improvement or reduction, however you look at it, in disconnects during the roam. 70%. When they changed out, same customer, when they then changed out the access points, it went to 99% reduction in disconnect.
That's incredible.
Yeah.
So
Yeah.
other than bots, what other applications do you see that require this sort of low latency transfer times?
Other than well, what I see most of the time is it's any mobile bot. So conveyors, right? Amusement
Okay.
park rides, right, Jeremy? I think you've got some experience with that. I mean, the one that I think ProSoft plays really well. What I call it our silver bullet is that ultra fast roam. So when you're talking about mobile bots in proximity with people, with a safety protocol running, it's that roam that's going to get you.
Mm-hmm. Yeah, and to kind of put some meat on the bones of that, the RPI being 20 milliseconds or 40 or whatever it is, on the one hand, just if you're listening right now and you're in an industrial environment and you can't figure out what's going on, a lot of times we'll come in and somebody that doesn't know what they're doing will set the RPI to like 2 milliseconds or 1 millisecond. They want to update this thing as fast as they can blast it, and then the radios can't keep up because then you're jamming it with traffic. But kind of on the back end of that, like balancing that, right? You got when you have your packet interval of 20 milliseconds, that's not necessarily like the constrictor for like how long you can go. Usually it's like you can miss 1 or 2 or 3 packets in that time. So really like your 20 milliseconds is 80 milliseconds, but you don't want to, or 160 if you're at like a 40, but you don't want to play around with that. You want the stuff to get there. So like having that like sub 10 millisecond roams that's like definitely crucial because a ton or 2 tons of force can do a lot more damage in 10 milliseconds than you think.
So Scott, I flaked out on you before when you asked that question. So in terms of the applications that we see, there's these ASRS systems, or automated storage and retrieval systems, right? Or these automated conveyors. So you think about the warehouses that store all the products that when my wife goes online and she orders something on Prime and it shows up like the same day. How the hell did that happen? This is sort of enabling it. But then there's conveyors in there, right? So there's AGVs, or not really AGVs, or AMRs, right? They're these bots that are driving around. And the signals we're talking about, they're getting a signal from what I call the traffic cop. It says, hey, bot 75, go to aisle 12, level 10, and grab that box, right? Because Vic's wife just bought it. There's automotive skillet lines, right? So you think about the automotive manufacturers, that cars are being built and they're moving along on these they're guided by like a track, but they're kind of they're traveling on their own. So there's the skillet lines, there's the electrified monorails. Think about, like, again, when the cars are being built, you've got the body of the car or the shell of the car coming up from on high, and that's being carried by a line, and then the skillet line is coming along. These have to be synchronized. All of those have industrial Wi-Fi driving them. So and they all.
I didn't know what a skillet line was, and I saw it in the show notes, and that's what I was pushing because that's really interesting. I didn't realize that Wi-Fi was playing that much of a role in the sync up of those lines.
So each one of those skillets, and it could be 200 of them that are following a track, around. Each one of them has got a PLC on it with a ProSoft radio talking to many fixed access points. So they're roaming from access point to access point, and God forbid you miss something during the roam and you stop the line. Then I've heard numbers upwards of $15,000 a minute in lost because a line goes down. You don't want a line to go down because your radio didn't roam fast enough.
That's insane. That's absolutely.
But this is why we said before that OT traffic is a lot different than IT traffic. And I heard you say you're sending video, you're streaming things, big packets,
right?
With everything we're talking about here, it's little packets, but you better not miss one, or you better not miss 2, as Jeremy was saying.
It's
so Vic,
small amounts, rapid fire.
I got a question, right? you know, when you talk about like downtime, I mean, that's, I've heard like even more than that in some auto manufacturers. But you know, if it's, have you run into the situation where the like the site IT doesn't really understand kind of the problem there, and you're trying to justify like, hey, you know, like you really need to address this. You know, you can't just do this with, you know, XYZ vendor that's in here, like you're losing time. We get pushback all the time where it's like it's hard to, you know, it's like they don't see that you know, stopping the line here and there, like in aggregate. I mean, you know, now it's like easier to visualize data, but I mean, I've seen it a ton of times where it's just like people bark at like, you know, $50,000-$60,000 worth of radio for like a subsystem. I mean, those can be cheap too. But you know, it's like you really talk about like you lose 4 minutes a day, and you know that thing's paid for itself in
Right.
you know, in a week, and you're like, why are we arguing about this here, buddy?
Yeah. I think it comes down to, and Jeremy, I'm sure I'm oversimplifying this, but if the guy you're talking to, and I'm gonna stereotype him as an IT, you know, network IT type of experience, doesn't understand how a PLC works, and you know the demands of a PLC, or God forbid the PLC to PLC communication requirements, it's just different than what they know, and they don't understand it. You almost can't blame them. They just never experienced it.
No,
Yeah, right.
Yeah.
you are 100% correct, and that is something I see at just about every site I go to, that corporate IT just doesn't understand the functionality and the needs that happen on OT versus IT. Because it's not about, you know, sitting there making sure you're getting your cat videos, or if you can print. You know, it's all about that machine to machine communication. And if
Yeah.
that can't happen, you know, if your PLCs or your DCS is not communicating efficiently and you're not getting that data through, and then those stops, not only is it a monetary downtime, but if it's a process as opposed to just discrete manufacturing, and that process doesn't stop in a certain fashion, uh, you know, especially if it's chemical related, then conceivably that then becomes an environmental event and or a safety loss of life event. So it just compounds and gets worse and worse. And as you increase that problem-o-meter, the dollar figures just keep skyrocketing. Because then
Yeah.
there's the unseen costs of reputation damage, you know, the unseen costs of what's my insurance going to do now. It goes from the straight downtime costs, and then just starts compounding from there, depending on what the process is.
You know, I've seen a lot of successful deployments where there's an IT person, I don't know if that's the right term, a network person on the OT side, you know, really understands it, and where on the IT side, they've backed off and said, just give us the data. So
Yeah.
I've seen that work out really well. The personality, the OT network professional working with guys like us, you know, closing the loop, making sure everything's tight on the OT side, and the IT guy, almost like he's on the other side of the fence, just saying, I need the data, just the data. Send me the data.
You figure it out and get it to me.
Right. And then he could
Yep.
do his analytics. He could do whatever he wants. You know, maybe we might do some edge computing on the OT side, but still, at the end of the day, he wants to see the data. He wants to roll it up to whatever he does. But if usually, like what you were saying, if he's involved in the design of the OT network, especially the wireless OT network, that's when you start getting products in there that probably shouldn't be there.
Exactly. I
And here,
could not agree more.
here's a very simple example. I've seen some places where they had, a deployment. It was kind of working, but something that drives me nuts personally, my own little pet peeve, it's really not a big deal, is when access points have their own built-in antennas. I don't like that. I like the flexibility of having to be able to put an antenna, first of all, to pick the right antenna, and then to place it where it should be, right, for the best spread, for the best access for whatever you're working on, as opposed to just taking something that looks like a garage door opener and mounting it to the ceiling. It has a built-in antenna and expecting that it's going to just cover everywhere. We've seen that.
I think internal antennas have their place in the IT world. I really, except in very specific instances, don't see where they have as near much of application in industrial manufacturing. Because you're absolutely right. You need that flexibility of being able to choose the right antenna for the job, but that also comes with you also have to have the understanding of how these antennas are, how they work, and exactly what their dispersion patterns are, so you can understand,
Right.
you know, and because I don't care how fast you roam, if you have crap signal because you're using a crap antenna, then you're going to have a crap end product, right?
That's right. That's right.
So,
Like for instance, so
okay.
anytime I work with a customer and you know, I can look at something and say, I usually can say like, oh yeah, I know this is going to work or it's not going to work, but I will not pick the antenna. You know, ProSource has a team of wireless applications engineers, and like they've been doing this for over 20 years. And I'm like, guys, here's the layout. Here's what it looks like. You tell me where to put the access points and which antenna. And they do this in their sleep. It's great.
That's awesome. You guys have been able to get in there on 802.11n chips. Was there much experimentation with 802.11 AC, since that was a 5 gig only technology? Or did you guys just not even bother with it at the time because you didn't really see any sort of enhancement to it for what you do?
We didn't bother. We intentionally skipped over AC.
AKA Wi-Fi 5.
Sorry, Wi-Fi 5, right. But now that, you know, Wi-Fi 6 has been out for a while, and it's funny, the engineers at ProSoft don't pick up the phone when they see me call, because I've been screaming for Wi-Fi 6, and I just start rattling off other companies that have it. So, but you know, we've had a challenge with the Wi-Fi 6, and you know, to not to get it into too much proprietary information, we currently don't have the ability that we have in the Wi-Fi 4 chip to reach into those low-level functions and control the roam, to do the calculation and control the roam ourselves. We're working on it, but that in and of itself has caused a delay in the rollout of the ProSoft Wi-Fi 6 radio, which is supposed to be out in September. But if we were having this conversation a year ago, I would have said the same thing. No, but that is the issue. That's the issue. So and the pushback, there's a little bit of a pushback. I see this, and I'd like to know what you guys have to say about this. I'm in a customer facing position, and I've got prospects that are doing 1,000 bots under one roof, you know, 700 plus under one roof. And they're telling me things like, you know, we need mu-MIMO, we need ODFMA, we need every bell and whistle that Wi-Fi 6 has that Wi-Fi 4 does not have. And so I find myself talking out of both sides of my mouth. I talk to, you know, ProSoft, and I say, here's why they need it, here's why they need it. And I talk to the customer and say, do you really need that? Do you really need that? So it seems like, you know, the market is asking for it, not to mention the eventual end of life of Wi-Fi 4, right? It's going to go away. But that's the challenge I see specific to ProSoft, but I would say to the other guys too, whether it's, you know, Phoenix, Siemens, Fluid Mesh, whoever it is. How do you get, there's all these beautiful new features that Wi-Fi 6 comes along with that I think makes sense to the enterprise world, but you know, how do you leverage your strengths, and in particular ProSoft's silver bullet of ultra fast sub 10 millisecond roam times? If you can get that working on Wi-Fi 6, great. But I don't know. I feel like I'm stuck between stay with the old or force through with the new. Curious what you guys think.
So, you know, we talked a lot about this in episode 7, and I think there are features in Wi-Fi 6 that make sense from a protocol stability standpoint that I think should be embraced. But if you cannot figure out a way to get the low roaming times. And so when you look at those who are doing it, I think the fastest competitor of yours would be Fluid Mesh, which is now Cisco Ultra Reliable Wireless Backhaul, because that's not hard to say, right?
Hey, I
I
gotta
mess
write that
it up
down.
every time.
Wireless backup.
But they're doing it.
WB.
They're doing it with multiple radios within the chassis, right? So they're not really digging deep down in. And then on top of that, Curb, it's its own proprietary protocol anyway, right? What's it using, Jeremy? MPLS, is that how it's?
Yeah, it's like MPLS over wireless.
So they're actually not even using 802.11 in order to accomplish that goal. And I don't think they're moving into Wi-Fi 6 territory, because that would mean moving out of their proprietary secret sauce, right?
Well, I think so on the newer hardware, it's kind of a one mode versus the other. But I think that they're implementing new features and stuff. But yeah, it's some of that stuff though doesn't matter, right? Because it's like you're not going to do WPA3 on their systems because it's like shared passphrase and stuff like that. And so if you're not like a curb radio, you can't really like talk into that system.
Yeah, you're not going to see it on a standard Wi-Fi scanner, because it's not 802.11. Really to see the traffic, you're going to have to bust out some spectrum analysis or use whatever super secret tool that Curb will give you to monitor.
Well, you gotta if you're on the network, then you get telemetry. You have to configure the radios to send it, but you get telemetry packets, and then you have to have some sort of parser, which we have some tools that we've developed for it. But you can scan it over the air. You might not necessarily know how to parse the packet, which so
you
then
just
still
made an
useless.
interesting point. You guys developed your own tool for it. The average shop can't do that, right? The average group that's deploying it can't do that, right?
Right. Well, and I think it's going to be commercially available at some point. But I mean, it's in the initial. I mean, if you look at the from the Fluid Mesh days, if you look at the Fluid Stats tool.
The CWNP Wireless IoT Track is the only certification program available that not only covers wireless IoT protocols in common use, but IoT as a technology and solution that is revolutionizing industry and business at the same time. When you work through the IoT track, you learn the protocols, the devices, the data, and the applications that bring the true value IoT has to offer. And for those with the tenacity to persevere, the world's elite IoT certification completes the process and the Certified Wireless IoT Solutions Expert credentials. If you want to be in the cutting edge of what's happening in technology, you won't find a better certification program for the Internet of Things.
I mean, it's pretty simple, but I still have nightmares about some of their graphs because you'd have to take a packet capture and you'd get this. They look really cool. You want to print them and put them on your wall, but it's just envelope after envelope of like all the radios that you see, and then there's one graph. It's like 10 graphs they pump out, and so you're trying to make sense of it. Where it's like, okay, at 30 seconds into this measurement, this vehicle was right here, and then trying to figure out like what your signals are, like trying to fix stuff that way. But yeah, I mean, it's just like the visibility is not necessarily there.
So then to hop another step, what about Siemens? How is Siemens accomplishing sub-second transfer times? Are they the multiple radio route?
Well, so
A single chassis, to measure and
the sticky kind of thing that we're seeing with Siemens right now is that they had that 788 device, and then they end of life that, which was like a dual radio, so you can still do IPCF where it's like the radio will hang on for as long as possible, and then it initiates a roam, but it's doing that point coordination function, so it's giving everything kind of a time slot as it goes. And then the IPCF MC was, radio one does like a single band across, and then it beacons out the management traffic and then broadcasts what its data channel is. And so you kind of like plan, you know, it's already got the roaming decision, but the mechanics of that, I don't think it's not as fast as, I mean, it's fast, but for safety traffic, but I don't know that it's as fast as ProSoft or Curb, either of those.
You know, and I know this is sort of changing topics a little bit, but you know, one thing that I'm excited about, and it gets again mixed reviews, is the 6E, right? The extended spectrum going to 6 gigahertz. And you guys tell me if I'm all wet with this, but I know that a lot of deployments we do now, just you know, regular Wi-Fi 4, we're always begging the customer's IT to you know give us dedicated. If we can get one channel, we're happy, or a couple of channels, right? Just like stay off these channels, right? But I've had customers ask us whether or not the ProSoft radio does multiple SSIDs, and we're like, no, we don't do it on purpose. We don't do it, right? We don't want the radio doing anything but being dedicated to what it's doing.
Mhm.
But what I see as a nice thing about with the 6E, Wi-Fi 6E, is that I believe it's like 60 more channels, something like that, some large number like that. That not only is it sort of fresh ground, nobody's playing there yet, but it maybe loosens up that little wrestling match between us and IT to say, please give us a dedicated, don't step on this channel. There's that many more channels for them to say, sure, we're not going to go there. But what do you guys think of that?
The one caveat I see to that, well, I see several, but the big one that comes to mind right off the bat is, in general, who is going to lay claim to that space first? Is IT going to, or is OT going to? All right. Now, we all know that in general, manufacturing is slow overall, not in all verticals, but for the most part, especially in the dirty stuff that Jeremy and I work in, is very slow to adopt new technologies. And typically they are 10 years behind just in general, right? So that being said, with 6E just being released last year, how long would it even take for industry to trust it enough to where they would actually start adopting it and putting money into it, versus IT, which there's already a ton of crap out there, that it's being built into standard access points, that on their next hardware refresh they don't go ahead and just build that in, because exponentially 6E end devices are starting to come around, and you give it 2-3 years and all of our phones will be 6E devices, whether we want them to or not. They'll have that capability, just because that becomes the new standard for consumer devices. But that's not the standard for industrial devices. And so how long is that process going to take for industry just in general to start adopting those frequencies, despite us spoon feeding them the reasons why you should? Now, I know in episode 7 we talked, I was like, I didn't really see much of a future for 6E quite yet in a lot of the stuff that I deal with. I personally, I do a ton of work in pulp and paper. So you're going up a frequency level, so you're actually increasing the reflective qualities of that signal, and you're decreasing the amount of obstacles that can penetrate. So in dirty manufacturing, that's going to start limiting, what you can use that for. However, if you're talking your ASRs and you're already using 5 gig, which is really a different ballpark than 2.4 as far as distance achievable at lower power, reflectivity, and penetration. It's not too terribly far off from 5 gig for you to adjust for in 6E. So for those type of applications, I really could see 6E becoming a new standard.
And add on top of that 1,000 clients, under one roof.
With the installability enhancements that come along with the newer protocol, absolutely.
Yeah,
Well,
I know I've heard many times the OFDMA and the ability for the one access point, and how I've heard the term airtime. The way it shares and sends the information to multiple clients versus the way Wi-Fi 4 does it.
Well, yeah, that's the big thing is your contention comes for devices competing for airtime. The hey, it's my turn to talk. No, it's I need to talk. I need to talk. I need to talk. And that contention for that airtime is what causes, communication slowdowns and delays, retransmits and whatnot. So
I think, my opinion on it is I hope that we can bully IT into taking over 6E and just these are not the hertz you're looking for. Give us the 5 gigahertz spectrum and just leave us alone. Let your laptops and stuff hit 6E out there, because there's is it a battery powered device? Can you have an external antenna? Are are you opening yourself up to a world of hurt, allowing your system to have external access to register your frequencies every day? There's stuff like that where it's like all that stuff is kind of wavy gravy in a sense. Like how do you resolve that? And there's not really, I mean, there's some interesting, like, that some people have been looking at those like lattice focus things. I think I was kind of telling you about that the other day, but there's some things where it's like the ability for the access point to put out more power than the client is really like the scariest thing for industrial, especially with like what Scott was saying, and like what you're saying, Vic, is like this stuff is going to reflect more. It's going to dissipate quicker in the air. It's going to attenuate, in our process things, right? The air is not necessarily like crisp, dry desert air. There's moisture in it. So it's like, that's variable.
well, let alone the machine interference. All the I'm a spectrum analysis junkie. I see most machine based interference I see in 2.4, but it's not unheard of to see it in 2.5, or I'm sorry, 5 gig rather. But I don't have the means at the moment to do spectrum analysis in 6 gigahertz to understand and get the feel for, is there any EMI RFI being generated by industrial machinery in those ranges, in order to, without a doubt say, yeah, you know what, that's a clean space for you to use, have at it. Does that make sense?
Mhm.
So there's still, gosh, still a lot of variables that go along with all of that.
And I like what I heard a minute ago, and I've seen this happen too, where the access point has the power, and it's and if you looked, and the signal's coming great to the client, so it's like the access point is screaming, but the client is whispering back,
Right, right.
the answer.
Yeah, it's saying, help me, please. I need to talk.
Well, and you were, Vic, you were saying that a few minutes back, you were saying, when the customer is saying, I want this functionality, I want this new greatest thing, and they're falling prey to all of the latest stuff that the advertisement guys, the marketing guys are throwing out there, right? It's all about bigger, better, faster, more. We got to have this latest and greatest. Why aren't we doing this latest and greatest? I want my system to be at 1.21 gigawatts so I can get that kind of throughput. Now I just need to hit 88 mile an hour.
Yep.
But in theory, you're not driving a DeLorean that can hit that 80 mile an hour. You're driving a big old Red Fox Sanford and Son pickup truck that can haul all this stuff, and it's not going to break 40 mile an hour, but it's going to do it reliably every single time.
No, you're right. I had an instance just this summer, back in June and July, where again, the customer was saying, he rattled off everything that I said before. He needed the BSS coloring. He needed OFDMA. And I said, why? Like, because I knew I didn't have it. This is sort of like a salesmanship thing. So, like those little pretty boxes you have behind your right shoulder, I said, here, I don't think you need it. Test this. And he did his proof of concept testing with the Wi-Fi 4 module. And a month later, he said, I need 400 of them. Like, it worked. Now, I don't expect that's going to be the case every time, but in this scenario that I just described, it was exactly what you said, Scott. He was looking for the new shiny nickel.
It's insane, because like I said, people fall for the marketing ploy stuff all the time. Is some of that stuff legit? Absolutely, some of that stuff's legit. But as with anything marketing, they're going to blow it up to sell the most units possible, right?
Yeah, and he gave me a couple of good arguments that it was tough for me to disagree with. One of which was, he said, well, what if I take my 400 bots and drive them all to the left side of the building? So now you got 400 bots on fewer access points, whatever, on that side of the building. He said we would do that at night, and in the morning they would kind of swarm out, right, and do their job. And I had a hard time defending Wi-Fi 4 in that position, other than to say, test it, right? Here, try it.
That's fair. On a side note, you mentioned BSS coloring. I have never seen that deployed, like, ever. Have you guys?
No.
If anyone
Not
listening
yet.
has either worked on or deployed BSS coloring successfully, please reach out and let me know, because I really want to know.
So let me make a dumb sales guy question. Wouldn't it make sense, like maybe, you know, in a residential apartment building where you've got people all around you with different RSSIs, and you want to like keep yours just thinking about your stuff and ignore everything else? Would that make sense?
Yeah.
I could see a situation for that though too, where it's like you know, if you have like kind of multi-tenant deployments in, because you know, Vic, you've seen this. I don't know how many like auto manufacturing facilities that you've been in, but you know, I've got some designs that just are really give me nightmares. But it's, you know, you got a skillet system going on the ground, you've got an AGV that pulls in at a certain point, and then over the top you got a carrier coming, and nobody wants to share the same access points. They need different, you know, each one of them's got their own like WLAN sitting there. And something like that might, you know, kind of give somebody the warm fuzzies that maybe we can coexist here, you know, in the same space. But I don't know.
I don't know. I don't know either, but I've seen, you know, another example where I thought about like, would this make sense or not, is like in, you know, some of these like large ASRS type applications where there's this particular client asked for multiple RSSIs in the ProSoft radio. We said no, purposely no. So then they went ahead and just get some more access points on different RSSIs and stick them around the outside for the engineers to debug the system, for the customers, workers to have their tablets and check inventory, all this stuff. So now, again, you got the same thing. We're trying to dedicate everything to the bots being perfect in this network of 400 or 500 bots running around. But you've got these right around the perimeter. You're adding different RSSIs for different needs. And, you know, maybe in a scenario like that, maybe the BSS coloring does make sense.
Who knows? Who knows?
Well, I don't think that it's a good approach to say, oh, it's garbage and it just cannot work. It's just, I have not, you know, it has not been pressed upon me to make it work yet. So it's like what's that, the running joke, that it depends.
Well, I mean, a lot of times industry is not going to, they don't want to be the test pilot for something new, because, you know, in order to deploy a lot of this, it's going to require a shutdown of some kind, and that's going to have to be recorded. That's going to have to be coordinated with, you know, pre-planned shutdowns, because they're not going to do just a shutdown to, you know, move over to another wireless system that they haven't proved yet. So,
hey, Scott, I don't know if you've done an episode on this or not, but you know, the biggest threat I see to all of this that we've been talking about today is, you know, private 5G.
but is that really a threat, or is that more of a synergy that can be taken advantage of?
It could be a synergy. So in one instance I've seen, and again, I'm basing this on one case study where the customer had two side-by-side ASRS systems, you know, Wi-Fi on one and private 5G on the other. And they, after a year or so of trying to get things worked out, they finally threw in the towel and just made that second system Wi-Fi, right? Got rid of the 5G. But I think that might, you know, that story might be different if it was played out 5 years from now. I don't know.
Well, that's true, but one thing is when you're looking at private 5G, what frequencies are they using? Most of what I understand is in the 3-ish gigahertz range, right? That's right in between your 2.4 and your 5 gig. Granted, it's licensed frequency, so you have a lot more control over that than anybody else using it. However, you're closer to 2.4, so you're closer to machine-based interference in general, from what I've seen in my personal perspective. But then the protocol is completely different. There's much more control over how clients interact with APs when it comes to cellular, because it's a completely different system, right? It's not based off of that whether that client wants to roam or not. It's the APs are controlling whether or not you roam and which one you roam to. So there's a lot more aspects of control over that are more powerful than Wi-Fi in general. But again, you still have all the fallacies of the frequencies that you're using. So I don't know, man. I guess I guess you really have to run proof of concept tests like this one guy did. Is it going to be cost effective to go that route? Or is it going to be more cost effective to go with the solution that you already know does 90% of your job and does it well? And what little bit of problems you have are acceptable overall based upon risk and loss, right? Versus the expense of a newer technology for industrial applications, rather. I don't know. I don't see a clear answer to it. So that's kind of that's a fourth entry into Wi-Fi Fight Club. So it's Wi-Fi 4, 5, 6, private cellular, So now it's becoming a tag team match, and who knows?
Well, the Wi-Fi 5 is the one that's like, mean girls, you can't sit with us.
Well, yeah, because it's 5 gig only, and it's
But there's somebody that I'm gonna have to go I'm gonna have to go do my favorite thing, go pester somebody that I don't know about it. But there's somebody that I've seen that's done a bunch of AGV deployments on. It might just be like CBRS or private 5G, but I think it can be successful. But it's people really don't like the mess, which you can't really get away from that now in a lot of senses. But that ongoing cost just to have the infrastructure there, not to mention like on top of hardware replacement and stuff.
Well, yeah, with license frequencies, you're looking at that reoccurring cost to maintain that license from the FCC, right?
Mm-hmm.
And I believe an significant initial upfront cost, right? Of the on-prem server.
Well, and we're also starting to venture in here something that I know honestly very little about in the grand scheme of things. All I have to base it on is my current knowledge of Wi-Fi and what little bit of reading that I've done on the subject as I've had time. So I would love to get someone on here who has done some OT private LTE deployments and just sit there and pick their brain.
Yeah, that would be nice to know. In my experience, and I, totally admit that it's my biased experience. It hasn't worked, but I'm sure there are cases where it has.
I have seen use cases for it out in the field for sensors and keeping it out of band with the primary OT network. And so it can carry all this sensor data up into the cloud and not be on the mission critical network, but it's still data that's related, but it's read only. And it's easier to place cellular out in the field because the cellular infrastructure is there. I don't know. I don't think there's an easy answer to that one. And I don't think there will be for a long time. There may never be an easy answer. At some point, every entity is going to have to draw their line on the sand and figure or not whether they're going to cross that or stay the course on where they are.
It kind of goes along with the same thing with Wi-Fi. With Wi-Fi 6. Like, is it the new shiny penny?
Yeah, and how much of that is the marketing hype versus what actually is going to work well?
I think with Wi-Fi 6 though, like kind of what we talked about on that episode, there's some of these things are not compatible. The Wi-Fi 4 stuff with like WPA3 is not available on several of the devices. And then you also have some of that, like the neighbor reports and things like that you can take advantage of and just make like, vanilla Wi-Fi protocols roam better. So you're kind of forced into it a little bit moving forward, but I don't think that it's like absolutely necessary, because really like you should be having good segmentation practices and stuff too. So it's like if somebody gets into your AGV system and like locked down, like they already have a port.
You've got bigger problems at that point.
Yeah, it's like it's kind of like the maintenance guy's still going to ask you to make the password.
Well, you know
Yeah,
what? I
guys,
will say this though, Vic. One of the biggest considerations is really to move to Wi-Fi 6 in general is the security aspect behind it with WPA3 because of what it enforces and the increase of the encryption algorithms and their size, right? But one thing ProSoft has done in its newer revs of firmware for its radios is it now enables management frame protection. You have that option, and so that alone addresses a lot of the fallibilities of WPA2. So when you can check that box for your ProSoft to ProSoft communication to enable protection for management frame protection, that's a huge leap in protecting your radios from deauth attacks, man in the middle, evil twins, that one security feature right there. So that alone takes you leaps and bounds for securing your Wi-Fi 4 deployment with those. So I can't really argue when it comes to ProSoft radios, the security aspect, when that one option that you guys had put in your firmware relatively recently, I want to say the past couple of years, because in older radios, I don't see that as an option, but as soon as I upgrade to the latest firmware, it's there. That one thing, that's a pretty big deal. Because 128-bit encryption, it's still the standard in most places. WPA3 is what's increasing that to 192 and in some cases 256. So, it's not so much that algorithm as it is, combining other security features. Does that make sense?
yeah, you got me thinking. It's funny in all the discussions I have with customers, like in a pre-sale type scenario. So much of the emphasis, the technical discussion is around the performance and the roaming and all the things we talked about. And even though it's there, the cybersecurity kind of like hangs in the background. Where I see a greater emphasis on cybersecurity is more of a remote access scenario where you're trying to, tie different sites together. And that's where we start talking about NIST 800, IEC
Correct.
62443. We even have like SHA hash algorithms, WPA3, things like
Yep.
that. You only use port 443. Like that, it's always up. But in the mobile robots under one roof, the ASRs type things, it's not the primary topic. From my
No,
experience.
it's because, and I say this all the time, when you're comparing enterprise wireless to, or just enterprise IT in general versus OT, in general, that CIA triad of confidentiality, right? Anyway, that it rotates because the triad has different importance with it's confidentiality. Your security is not top dog in OT. Availability is. Availability followed up by integrity. Okay, so that's first and second. So your confidentiality, that's security. That's a bolt on. That's a nice to have because we have to have this data right here, and that data has to be complete. You take your CIA triad and you rotate it and you flop it over, and so it's no longer CIA, it's AIC.
Yeah, I see.
Yeah.
And it's priority.
Exactly, and it's that same principle holds true with industrial wireless communications versus enterprise wireless communications. If you ask me,
no,
in my opinion, which I hold very highly.
And I think of some of the real long-term sales cycles, upwards of 2 years from starting to talk to a customer to they buy proof of concept till they actually accept it and start really buying it, like from an OEM. I'm hard pressed to think about how much time in there was spent on security in an industrial, wireless, Wi-Fi 4, mobile bot type application. Remote access, it's the first thing you're talking about.
Right.
You're connecting multiple water, wastewater sites via cellular back to a SCADA. It's all you're talking about.
Right.
It's security.
Yep. You're absolutely right. Man.
Well, that's with the nerd knobs you're talking about earlier, Vic, where it's like they want everything turned on that they can. that also falls in a different triad that I call the CYA triad. Cover
Yep.
your A, you know.
Yep.
I'm not sure I'm familiar with the CYA triad, Jeremy. Can you explain that to me in greater detail?
Well, it's like in Y2K, where it's like everybody bought the main name brand devices for their network stuff, because if it was wrong, everybody was wrong, and you don't get fired because you bought the absolute most expensive thing you could.
Actually, after being married 22 years, I am intimately aware of the CYA triad. So
I got an "it is fine" text the other day because I forgot to grab something out of the car before I left, and I was very worried.
you should have been, because we all know when she says it's fine, it's not fine.
Well,
You guys
she
got
was gracious about it though, so I came out unscathed.
That's
but
a podcast for another day.
Scott. So Scott, after 29 years, I don't even cover it because nothing I found that covers it protects it.
So really, when we look at our Fight Club, there is no clear winner, right? Yes, there are advancements in technology, but is there a true use case to advance to the next technology that's really important to what you're doing versus to what is being screamed at you by the marketing people, right? So with these different technologies in the ring, they're all swinging at different things, really, when you think about it, because they have different applications that they're best for. So until we can figure out if the newer stuff can maintain the status quo that the older stuff was able to do, and in this case, we're talking fast roaming, right? So that is a shortcoming from the industrial point of view on Wi-Fi 6 in general, right? Because you don't have, so then that means you're going to have to get creative and figure out other ways to do it, whether it be multiple radios in a box in order to handle that, to get you that sub-millisecond handoff, the sub-second handoff times, while still dealing with some of the other enhancement, or are those enhancements even important for what you're doing?
Is Wi-Fi 4 going end of life?
Not that I'm aware of. I have not seen anything. I mean, I don't think the spectrum is going anywhere. I have seen nothing that the FCC is saying, all right, we're going to take 2.4 away because entirely too many devices use it, right?
Well, maybe from the point of view of the chip manufacturers.
I don't think so, because they're still making mad money off of it because they're cheap to produce, right? And not to mention, look at how much in the IoT space is built off 2.4 gigahertz. That's going to be around a long time. And then you look at industry specific protocols such as wireless HART and ISA 100. That's all 2.4. I personally don't see 2.4 going away as a spectrum. Do I see Wi-Fi 4 going away eventually as a protocol technology? I think eventually it will start falling to the wayside like wireless G has. Eventually, but you're going to have to overcome some of these very specific things that we're talking about today in order for it to start falling to that wayside. Because once the actual use case for using it fades away, the use of it will start fading away, right? And then finally it'll get to the point where right now in deployments, everybody tells you disable wireless B. We know it's backward compatible, disable it. It's going to, you don't need it anymore. How much longer is it till we're told to disable wireless G? Is that even an option? Because N is built upon G, right? B and G are actually kind of different. So you can disable B and not affect G, right? It'll be interesting to see how that plays out over time. So, I mean, there's no clear answer and there's no clear winner. It's a 4-man rumble, but everybody's swinging at different things. And I think it's a comedy of error because nobody's hitting anybody, right? Because they're swinging at different things and they're not making contact with each other. So as far as a fight, it's really not a satisfying one.
I think, yeah, Wi-Fi 4 is kind of like the fighter that's kind of still capable in the tail end of its career, and you don't want to get in there mix it up with it. I think the cost though, right? That from what I've seen, I know, like for example, the Siemens Wi-Fi 4 client and the Siemens Wi-Fi 6 client are, for at least the in-cabinet one, are pretty comparable in price. So it's like, in a way, it's if you're going into a third-party infrastructure, for us, it kind of makes sense. Like we've been kind of trying to move towards using the Wi-Fi 6 device to get some of that stuff because the customer's kind of deciding that for us is that, hey, we're going to require XYZ for this to kind of cohabit on our corporate, like the ITW land that's out in the plant floor. But it's yeah, like it's all kind of like, I think it's going to all be kind of customer driven, but some of the lesser stuff like is still, I bet there's still going to be like a long life for it in those types of devices for the reasons you said, Scott.
Well, it's all about application, right? Sure, they want the big, shiny, new, bigger, better, faster, more. But will that work for the application that they're trying to use it for? In this case, for what we primarily have been talking about, we've primarily been talking about bots and roaming. Is Wi-Fi 6 going to be able to satisfy the ultra-low roaming times that many of these things require, right? And even things that aren't mobile, but still require ultra-fast times, with SIP safety and different things like that are run across wireless. Or mobile but slow moving, but you still have to have that sub-millisecond transfer time. I do, like, again, I do a lot of work in pulp and paper. Where I use a lot of ProSoft stuff is on cranes, both inside house cranes for smaller gantries as well as larger outdoor cranes. A lot of times it's involved with anti-collision systems. Okay. And so if you've got radios roaming, the last thing you want is an extended roam when you're trying to keep two cranes from slamming into one another, right? Not only does that stop the process, I mean, it quite possibly can kill your operators, and then hundreds upon hundreds of thousands of dollars of equipment damage on top of that. So it's not like these things are out there with Lightning McQueen winning the Daytona 500. No, they're slow moving, but it's just as important, that low roaming time, in order for them to be able to stop when they hit that e-stop, for those safety protocols to function properly. So will Wi-Fi 6 be able to fill that need? Will it be able to work in that application? And I think that's a discussion that guys like us have to have with our clients in order to open their eyes, when 9 times out of 10, all they see is what the commercial they're seeing on TV.
Yeah, you bring up a good point. I was talking with somebody the other day, and we were talking about, in one application where the bots were doing like 30 miles per hour and they needed fast roaming. And in another application, like self-driving forklift trucks, they were doing like 5 miles per hour and they needed fast roaming. And the question was like, well, why does it need fast roaming? It's moving slow. It has nothing to do with the physical speed of the
Correct.
bot. It's the time.
At NASCAR racetracks, these guys are going 180 mile an hour. They've got radios in their car and they're fast roaming. That's really fast roaming, but it's that same transfer rate. When you look at curb with high speed rail, that's you have to have that because of just the speed the objects are moving. I get that, but that principle applies for the protocol. I don't care how fast or slow you're going.
We got some like 2 meter a minute carousels that we work on. It's like, and you drop packet on there and then they'll just crap out. Yeah, it's not all tortoise in the hair,
Well, guys, this has been an outstanding conversation. Vic, I cannot thank you enough for coming and hanging out with us here at the Industrial Wi-Fi Shop. Honestly, I hope I can talk you into coming back at some point to talk more about this stuff, because this has been great. I've really enjoyed it.
Yeah, no, I did too. Thanks, Scott. It's always a pleasure talking to you. And thanks, Jeremy. And yeah, anytime, I'm around.
Thanks for listening, everybody. And we hope you join us on our next episode of the Industrial Wi-Fi Shop.